Hello, folks. This is part 16 of learning Rust from scratch, and I was actually writing some stuff on, Rust Playground and trying out some stuff. And I think the last section we looked at was functions, and we still have comments and the control flow remaining in third chapter. After which we go to ownership, understanding ownership, what is ownership, references and borrowing, the slice type. Right? Before that, I wanted to talk about how I can actually implement some of the algorithms out there. For example, XX hash is a popular, extremely fast, non-cryptographic hash algorithm. A lot of people have implemented it in different languages. It's been implemented in C. I don't know if it's a research paper, I don't know, but it's an implementation. It's a great implementation. And there are a lot of implementations of it. I think Rust, there are two of them. Unfortunately, there are already two crates. 2x hash is one, and xx hash rust is one more. The code looks a bit weird, xx hash underscore rust and then const underscore xx h3 and whatnot. I don't know why the naming is like that. Um, and xx hash, someone has already picked up the crate and someone has implemented it. Um, and 2x hash is the other one. I think it's called 2x hyphen hash. And I think enough people have started this. And the same is true for this also. Like some 200 people have started this, and some 392 people have started this. So I might implement these. And yeah, I mean, I could implement more stuff. This is one of them. And yeah, I mean, I can also implement stuff like Google's Level DB, I think. GitHub, Google has a thing called Level DB, which is actually a C++ fast key value storage library written at Google that provides an ordered mapping from string keys to string values. Level DB, and I can also write many other C++ stuff. I can try to write them in Rust. I wonder how much of Rust has C++ in it. Maybe I'll ask Gemini.google.com. Let's see if it comes up. Yep. Does Rust have any C or C++ code in it? So I'm asking the 2.0 Flash. I'll ask the 2.5 and 2.5 Pro and Deep Research. So while Rust is designed with memory safety and high performance as code in it, and it has its own compiler and standard library, you can primarily Rust. It does interact with C and to a lesser extent C++ code in several ways. Function interface. Okay, foreign function interface, FFI. Okay. Foreign function, I thought it was invocation, FFI. Okay, foreign function interface. So Rust has excellent support for foreign function interface, allowing you to call functions written in C and to be called from C code. So from C you can call Rust, and from Rust you can call C. This is achieved through the extern C keyword, which ensures that Rust functions adhere to the C application binary interface. ABI is a standard. C ABI is a standard that allows different languages to interoperate at a low level. Okay, I didn't know that. Interoperability with C++ is more complex because C++ does not have a stable application binary interface. Okay, however, Rust can interact with C++ code by going through a C interface. C++ functions can be declared with external C to make them callable from C and this Rust, and provided they only use data types compatible with C because C++ has class and C does not, I think. So Rust often relies on the operating system libraries, so which are typically written in C. Okay, so for instance, when a Rust program needs to perform tasks like input-output networking or interacting with the operating system kernel, it often does so by calling functions provided by these C-based system libraries. Okay. Build tool and linking, I think it does require, I think, some linker of sorts. I can't recall which one. The Rust toolchain, including the Rust C compiler, often utilizes the system's linker, which is frequently written in C, C++ on Windows, for example, the C++ build tools package is often required because it provides the necessary linker. I think this is the same thing true for even macros. Rust build scripts build.rs can be used to trigger external build systems like make or CMake, which are not commonly used to build C, C++ programs. The CC create in Rust also allows for direct compilation of C, C++ code within a Rust project's build process. So tools like binds and bindings generation interoperability creates. Okay, so let me actually ask this and show the content. So yeah, uses the LLM low-level virtual machine backend for code generation and optimization. There's a large and mature compiler infrastructure that is primarily written in C++. This means that the process of compiling Rust code into final machine code often relies on the C++ component. But does the final machine code, my machine code should be some assembly code, so it's not C++. So I think that's fine. LLM is the default. There are alternative backends for Rust C compiler being developed, such as the Cranelab, which are entirely written in Rust. Using such a backend would allow for a compilation process that does not depend on the C++ code base of LLM. And the standard library, the Rust standard library provides a layer of abstraction over the underlying operating system for many low-level operations, such as interacting with the file system, networking, and threading. The standard library interfaces with the C standard library libc provided by the operating system. This involves calling functions written in C, calling function interface. Okay. And what about experimental? Get emails, get updated. Just a moment, there's an insect on my laptop. Just a moment. Okay, so let's actually just go ahead and I'm gonna read the answers later, but it looks like the answer is almost the same for everything. Um, Start research, analyze results, create report, ready in a few minutes. Show thinking, sites browsed, interesting, deep research. So compiler implementation again talks about the same stuff. So can I actually open this in a new tab? No, tricky stuff. While this is going on, let me actually put this. And it's standing in C, C++ code in significant ways, although the core compiler frontend is written in Rust itself. Okay, so the front end is still Rust. The back end is LLVM, and standard library provides essential functionalities. And again, networking, threading, interaction with the operating system, I/O, input, output, everything is all to operating systems libraries, which is typically written in C, APIs, application programming interfaces. System calls often via the system's C standard library libc on Netflix systems or Windows API. Rust generally contains wrappers and bindings written in Rust that fall into these C interfaces. Okay. The very first Rust compiler was written in OCaml. It was then used to compile newer versions of the compiler written in Rust itself. Um, a process called bootstrapping or self-boosting. Okay. I think it was written OCaml, and OCaml started using that, using OCaml to process Rust code to create, compilers. You to use to compile new versions of the compiler written in Rust, and you got the latest compilers. Interesting. So now this is still going on. I'm not sure. Is it done? Yeah, it's done. Yeah, it's done. Deep research, generate audio overview, sources read but not used in the report, thoughts. Interesting. It's a lot of stuff. Interesting. So, oh, I just have to do this and it opens it up. I don't know how to click it for it to open it. I can just hover over and it opens it up. Okay, anyways, personalization. Anyways, while this is happening, I wanted to actually talk about how we can implement level DB in Rust, and maybe I stuff like, I don't know, B. Johnson, about Ben B. Johnson's Bolt DB, um, and you know, we can implement Bolt DB in Rust, or we can implement Redis in Rust, or basically Valkey in Rust, Redis, Redis itself in Rust, or Valkey in Rust, right? And what else? etcd in Rust. So ZDC, etcd, etcd, everything in Rust. And stuff like databases, PostgreSQL in Rust. There's this thing called Neon database, which is actually serverless PostgreSQL, and it's written in Rust, by the way. So that's pretty cool. And then when I was looking for Neon, I noticed that there's something called Neon bindings, um, which is actually the Neon project. Rust bindings for writing safe and fast native. To build crash-free native Node.js plugins with Rust. So Node.js plugins, modules, or packages, or dependencies, whatever you want to call it. I think this guy is pretty popular. I remember seeing him on Amilaja. So it looks like he's actually building something cool. Um, oh, hey, monitor your Rust performance. Anyways, so apparently he's hiring, and yeah, I'm now in the rabbit hole. So the last thing is Neon. Basically, these are Rust bindings for writing safe and fast native Node.js modules. I think this is possible mostly because Rust can actually compile to Wasm. So cargo.toml, if you see, I think it should say Wasm. That should be the target, I think. There's no target here. Interesting. Profile release is this. Is there a Wasm? No. Web assembly? Nothing. Interesting. So see a Neon Fundamentals docs, and one moment. What about cargo.log? Web? Nothing. ASM? Nothing. Assembly? Nothing. Interesting. So web assembly, I don't know how it works out though. Neon is apparently a library and toolchain for embedding Rust in your Node.js apps. So basically, um, I think how this starts up is they have a way to actually create a program which is actually a Rust crate, and This is a Rust script and also a Node.js package or a module or an npm package. So how to and was using Neon API reference docs. I think is pretty small. API reference, I think it's pretty basic. It's not too much. I don't know how many people are using this, but there are like 8.2K thing, and I think this is the guy who wrote it. I'm not sure. Dave Herman and over there, and it was this, and Neon, Iron's dynamically loaded binary modules. So binary modules with a safe and fast Rust API. So I don't think there's much information around how this works. And okay, this is Anila's also, so probably some old stuff from 2021. Anyways, so I can probably contribute to that, and I can actually check out stuff like streaming replication for SQLite and whatnot, or the company that Bevan Johnson works at, which is Fly.io, and probably implement these Golang programs. Um, so, for example, and they have their own one Rust, thing. It's called Corrosion. It's a gossip-based service discovery and more for large-scale distributed systems. So, pretty cool stuff. I can probably contribute to this. So, oops, it's nothing much. So, yeah, I mean, what else do they have in Rust? I think they have more stuff. Corrosion is one. This implemented as a Rust library, and looks like there are two of them. Is this a this is a fourth? Looks like it's a fourth. Sanji, someone is this will implemented. Who is Sanji? Edison? Building Country's data platform with their time team, open source enthusiasts, favorite languages, closure and Rust. Interesting. I am also kind of into databases. So Country's database for the cloud era. They're building it in Rust. Awesome. I can't think differently. Of course, it's awesome. So they have support for SQL, Prometheus SQL language streaming available on Grafana Cloud, and unified observability database for metrics, logs, and traces. Demo scene. Um, so I think Rust is their main thing, so I'm not surprised. Protobuf, Bronchial parser, and a lot of stuff. Interesting, interesting. Extension for more hyperfunctions, fully compatible with timescale, DB, and PostgreSQL. PCAP analysis library. They have a lot of interesting stuff. Nice. So vector indexing and such library. Okay. This is actually the vector thing, vector.dev. And cool. So these are some interesting projects that I can contribute to. And so again, I got into the rabbit hole of checking out some interesting projects in Rust. So this is also an interesting project in Rust. So Vector, which is an open source software which was created by Datadog, and now it's being used by many people. A lot of people use it. Datadog, you can see. So developed with love by Datadog. So yeah. And Datadog projects, yeah. And you can actually probably find out if there are no Rust things here. So yeah. And yeah, I can take up any Golang program or Python program or anything and write it in Rust. For example, I remember long ago I used to think about how Rust is there for WebAssembly, and then I can write a data frame library in Rust and provide it for WebAssembly for JavaScript for really fast speed. And someone has already, of course, done it. And for example, you can actually see in my, I mean, of course, this was only an idea. You have to execute it, right? I didn't even know much about data frames and all that stuff back then. Data frame Wasm. You can see over here, I created this in 2019, right? I was just planning on like trying to do something of this sort, and the idea was to write it in Rust, um, and use Wasm and like Wasm can be fast and a lot of things, uh, compiled to Wasm. So someone has actually done it. Rust data frame. There is Polars. I think this is the one, and this is in Rust. I think this also supports Wasm. I'm not sure. JavaScript. Yeah. So it's there in JavaScript also. Node.js Polars. So in Python it's Polars. In Rust it's just Polars and this version. And I think Node.js Polars is probably just npm.js slash package slash Node.js Polar is probably just a Wasm version of its whole thing. I'm guessing Node.js Polar RS, nice, no? Um, so RS is the Rust. So documentation, importing, so build, is there a cargo terminal? Yeah, there's a cargo terminal. And dependencies are ahash, bincode, we have a polar score and everything. Is it Watson target? I can't find the target. Names. I want the build dependencies, profile release, features. I wonder if they use Watson here. Anyways, Rust toolchain. Interesting. What does that mean? I don't know. Not clear here. So, not sure how they've done this, but they use Watson and ensure that they use Rust. That's pretty cool, by the way. So, I think compile Polars from source, install the Rust compiler, and fastest binary, very long compile times, debugging fastest time. Webpack configuration, development of Polars is probably powered by some Impacted AI. Oh, great. So it's an open source project, interesting. So Node.js front end of Polars, right? It's only a front end. Behind the scenes, it's still Rust, I think. Let me see what they use in the package.json. Right? This should have the module, right? Where it starts the main. So binary index.json and then basically source. Let me get the source. Go to the wrong thing. Interesting now. Or even just have Pola RS and Node.js. Anyways, source and then index.js. Oh wow, there's no index.js. Index.js. So I think it all compiles to that then. Is there a Webpack JSON or a what other JSON files do they have? They have a Bloom. What is a Bloom? They have TypeScript. I'm not sure what is this. Is there an index? So I think TypeScript is doing the build. Let me check script configuration. Include compile options and is there an index.js? Entry points is index.js. Polars, and then we have that. Okay. Index.ts is the index.json, I think, in JS. And okay, so it brings up data frame from data frame and it comes from node stream functions, internal construction, array to data, it's JavaScript data frame. It's doing a lot of stuff, data types. So import, where is the export coming from? Export df, export interface. So these are the exports it's doing. And I think these must be coming from some Rust thing. Rust crate. Okay, so there are some Rust crates. So yeah, and I'm not sure if it's using Watson, but the library is intended to work only with server-side JavaScript TypeScript. Basically, Node. Basically, it should have a Node runtime. If it's browser runtime, you have to see other stuff. JS Polar. This will have Watson, WebAssembly. Is it Watson? Yes, this is Watson. JS Watson bindings for the Polars library. Please be aware that this package has significant startup overhead when running the browser due in part to the size of the Watson binary, as well as spawning of workers and directives. Okay, this will be slow. The startup is there, but overhead is there. Only using this file in cases where the benefit of the features it provides outweighs the added startup overhead. Okay. So yeah, that is one thing. So we can actually even work on Rust over here and Polar are interesting stuff. So we are hiring and they have careers and whatnot. I thought this is being sponsored, but looks like this project is by a company and they're hiring. So yeah, power bindings and whatnot. And there are many more nice projects, around Rust. So and we can always, of course, implement a lot of C language, C++ stuff in Rust. For example, ClickHouse is written in C++. Um, it's written in C++. That would be very, very ambitious, but of course we can do it. Timescale, which is written in again C. You can see here. C. There is some vector search, a complement to PG Vector for high performance, fast efficient vector search on large workloads. Toolkit for more thing, or that is here. So timescale, and then there is Prometheus. So this is written in Golang, and then you have PostgreSQL itself, right? I think PostgreSQL is now Postgres, is it? I don't know. Yeah, so it's Postgres, redundancy, and then stuff like Java projects like Cassandra, um, or on Apache. I think Cassandra is probably here or not here, I don't know. Superset or Spark or Airflow, all of these we can actually probably try to write in Rust and see how it goes. And we can actually write, for example, Dice, these are database written in Golang. And then you have Facebook's stuff, like interesting how Facebook fits to this and Meta. Oh, someone has Meta already here. And Facebook leads to this. So you have ZSTD compression algorithm in C. You can actually implement build system buff uh, it's already in Rust. You can just contribute to it. Um, the first version I think is buff.build, and this is buff2.build. Um, so this is buff. We use buff2 please for the build system that replaces it. Old content continues below for historical requirements. So it's ready for users for Python, Rust, and all that. So it's a large scale build tool, and there are also a lot of Facebook interesting stuff in C++ and in Rust apparently. So C++ you can see that they have, for example, I think they have a storage engine of sorts. I forgot which one it is. Okay, they have an implementation of the quick transfer protocol in C++ called MVFST. We can implement the quick protocol. It is one of the latest protocols for I think uh, instead of PC. Yeah, it's instead of PC data. So I think quick transport protocol is an alternative to TCP, think, developed by Google, designed to improve the performance of web applications by reducing latency and enhancing topics. Okay, it's operates over UDP, and so you can actually see that they have a lot of stuff in Rust, and their C++ stuff is also a lot. We can actually see open switching systems software for controlling networks, such as interesting. Runs on Apache Thread, including MS C++ server. I think they have this, yeah, ROX DBS. That's all. A library that provides an embeddable persistent PID store for fast storage, and so level DB and then stuff like that. And we can also implement, so for example, they have MySQL server and all that. So we can implement even databases. But that's going to be pretty huge. Very ambitious. But yeah, this is Oracle MySQL server. And yeah, we can implement RocksDB in Rust if needed. It has 30K stars and it has 30,000 commits. So if we are trying to actually implement the same thing, it's going to be pretty big, I think. But yeah, it is built on earlier work on LevelDB by Sanjay Ghat and Zephyr. I think this guy is pretty huge. So the LevelDB is actually a pretty big paper. Um, and so yeah, actually Sanjay Ghat is actually popular guy. So this is the guy. He has done some interesting work in databases, and so yeah, I mean, he has actually written a lot of research papers.